Thank you. Thank you for having me here today. My name is Samuli. I'm a software engineer at Protocol Labs. I work on IPFS and more specifically on dynamic content, so distributed peer-to-peer applications. One of the applications I've been working on is called Orbit, a peer-to-peer chat application on IPFS, which we just integrated with Uport. You've already seen it earlier here today. And the marriage of these two technologies is beautiful. So today I'm going to show you Orbit with Uport and talk about how we build completely distributed applications today. And also what we should consider when we build our applications for Web 3.0. So if you heard me talking about Orbit before, you may have had some doubts about the distributed nature of it. But today I'm happy to announce that Orbit is finally completely distributed and peer-to-peer. There are no servers involved. So I'm going to jump right into the demo and show you the cool stuff. Can you play the video, please? So when I open Orbit, I can log in simply with a nickname, or I can use Uport. When I choose Uport, it will prompt me to authenticate the application. I scan the QR code with my mobile app, and Orbit will pull the profile from the blockchain. Now, when I log in the first time, Uport will ask me to sign my Orbit key, which then gets added to my Uport profile and will work as the public signing key for the messages that I'm sending in Orbit. So once I'm logged in, I can join DevCon 2 channel and start chatting. One of the really cool features of Orbit is the file integration with IPFS. So I can drag and drop files and folders directly into the chat and share it with the channel. Code, pictures, video, audio, they all kind of pop right in, and you can start directly streaming the videos from the other users. Now, what Uport gives us is the verification that the messages from HUD are really from me. If I click on my username, once I'm done making bad jokes, you can see the Uport profile data right there. So my name, my location, provider is Uport, and the public signing key that I just added to the blockchain, and which is used to sign the messages. This is extremely exciting. I know who I'm talking with, and I can verify the source. This Uport is really cool. I love it. Thank you, Christian and Consensus. So I wanted to show you another cool demo, which I didn't have time to finish. But this is called Planet Express, and it's kind of like Twitter. You have a feed where you can post stuff. You can post from repost from other users. You can pin them. You can comment on them, and so on. And it uses the same technology as Orbit does, including Uport. This is really sweet. And what you just saw were completely distributed real-time applications with verifiable blockchain-based identities running on desktops and browsers today. This is what serverless architecture really means. And let that sink in for a while, because this is absolutely huge. We've come incredibly far in just a few years. Underneath Orbit, there's a peer-to-peer database called OrbitDB. It gives you various types of databases. Event log, where you can only add messages, but you can't delete them. A feed is the same as event log, but you can also delete messages. A key value store, just like any other key value store you know, but peer-to-peer. And counters, which are really useful for stuff like votes and likes and so on. You can also easily implement other types of databases like index document store, kind of like MongoDB or so on. OrbitDB uses IPFS lock for database operations lock. It's an append-only, partially ordered, eventually consistent Merkle tree of database operations basically a linked list of IPFS hashes. So having an operation log allows us to use CRDTs. They basically allow us to merge data in a way that there are never conflicts. I would highly recommend you to look into CRDTs. They're extremely cool data structures. So once we have distributed data structures in place, we need to replicate the data between the peers. And OrbitDB uses IPFS PubSub for propagating the database operations from the operation log to the network. So in Orbit's case, when I send a message, the message gets created and signed with my public signing key, the one that was added to my Uport profile. We then add the operation to the database, and the head hash of the operation log gets sent to PubSub topic, which in this case is the name of the channel. And that's how the data gets eventually consistent across the peers, and everyone sees the same data. So OrbitDB works really nicely for application databases, and it's quite performant, but there's no saving of the database. So what would be really cool is to timestamp the head hash of the log or snapshot it periodically into the blockchain. You may think, why so complicated? Why can't we just replicate MySQL databases between the peers? In distributed systems, time is a very subjective matter. And without a central authority, we don't know what the order of the messages are. And this is what the CRDTs solve. And this is why they work so well in distributed systems. So we have IPFS for storage, an append-only log for data transport, CRDTs to create databases on top of the storage, and we have PubSub for super fast message propagation that enables peer-to-peer replication. And we have Ethereum for authenticating and verifying data, people, transactions, payments, and so on. Combining all these, we finally have all the primitives that we need to build truly powerful distributed peer-to-peer applications that also work in the browser. Different types of databases, dynamic content, even live video streaming is possible. I can't emphasize enough how profound this stack is. So with these new superpowers, we should also consider what and how we build our applications. We don't want to just blindly follow the Web 2.0 paradigms, and we need to consider what are the properties of distributed applications. Today, pretty much nothing works if you're not connected to the backbone. This is a huge, huge problem. We need to make sure that our applications work offline first and foremost. There's a new trend in web development called progressive web applications, which is a great direction, but with these technologies, offline becomes an inherent implicit property, and we can make it so much easier and better for all the developers around the world than it is today. This should be pretty obvious to the crowd here, but let's make sure that our applications don't depend on services that can just disappear, can be shut down, or otherwise just cease to exist. We're pretty much locked in with our data to the services we use today. We can't share data between applications, let alone have any control over our personal data. This is not cool. This is not the internet we wanted. We need to make sure that the applications we build can share the data between other programs. You know, use linked data to create relationships between the nuggets of data, and use standard data structures as much as possible. So, you know, like a chat message in one chat application is probably the same as it is in other chat applications, and a feed is just a feed viewed and packaged differently. As we develop our tech, we also need to make sure to provide a smooth integration path. Otherwise, the revolution will not happen. This is crucial to gain mass adaptation. Application developers don't care about deeper layers of the stack. They just want something that works, that they're familiar with, and something that works with the technologies that they use today. So as an example, OrbitDB provides a key value store, which on the API level is exactly the same as key value stores we have today, except it's peer-to-peer. So, like I said, we've come really far, incredibly far, just in a few years. And you should all be very proud of what you've built so far. But there's still a lot of work ahead. And I want to leave you with something to think about. How can we achieve or solve some of the remaining problems that we still have?
You can have this one.
Thank you. So the way Uport does authentication is fantastic. Like I said, I love it. I wonder how we could use the same or a similar mechanism for doing permissions in a more general way. The mobile use case is a very different from desktops and servers. So how can we make all this happen smoothly on the mobile web? And you may think this is pretty out there, but think about the future of the humankind. We'll soon reach Mars, and maybe beyond even in our lifetime. So how do we make truly interplanetary applications that can work across vast distances, time spans, and disconnected networks? My personal goal is to put orbit on orbit. Thank you.